Okay, let's work on lesson 15.2. So we're going to be constructing geometric sequences today. So here we have, as hinted in lesson 15.1, we can find any term of a sequence by repeatedly multiplying the first term by the common ratio n minus 1 times, or by the common ratio raised to the n minus 1 power. For example, suppose the first bounce of a bouncy ball is 96 inches. And for each bounce after that, really quick, I just want to explain what this is saying because it sounds really complicated. But if you remember, let's look at the sequence like 3, 6, 12, 24. We can find that the common ratio is going to be 2, and that's pretty obvious because we multiply by 2 to get from one term to the next. Now, to go from the first term to the second term, we have to multiply by the common ratio once, right? And then to get to the third term, we'd have to multiply by the common ratio again, so twice. And then to get to the fourth term, how many times do we have to multiply by the common ratio? 3 times, right? So to get to any term, we have to multiply by the common ratio one less time as the term number that it is. So to get to the fourth term, we have to multiply by the common ratio 3 times. To get to the third term, we had to multiply by the common ratio twice. So that's what all this is saying. But anyway, for example, suppose the first bounce of a bouncy ball is 96 inches, and for each bounce after that, it only rebounds half as much as the previous bounce. Since we will multiply each bounce by 1/2, it is our common ratio. So starting with the first bounce, f of 1 equals 96, we will repeatedly multiply the common ratio, r equals 1/2, to obtain the height of each bounce. So it already told us that the first bounce is 96. So the first time the ball bounces, it's 96 inches high. And then the second bounce will be half as much as that, so we have to multiply 96 by 1/2. Which is just 96 divided by 2, right? And which, could you get out your calculator for me to work on that? 96 divided by 2, you should get 48. And then for the third bounce, we're going to take half of 48, right? Half of 48 is 24. Or if we want to think of what the height is from the very beginning, we take the first term and multiply by 1/2 twice to get to the third bounce. And then to get the fourth bounce, we have to multiply by the common ratio 3 times. So we're just going to divide the third one by 2. So that's going to give us 12. We then write each of these as exponents. So to get obviously the first bounce is 96. To get the second bounce, we multiply the common ratio to itself once. To get the third bounce, we multiply the first term by the common ratio twice. To get the fourth bounce, we multiply the first term by the common ratio 3 times. Right? Use this pattern to find out the fifth term as an exponent. So that means that f of 5 is going to be 96 times 1/2 to the what? To find the fifth term, we have to multiply the common ratio to it to the first term 4 times. Notice that the value of the first term, f of 1 equals 96, is a factor in each of these subsequent values. So that just means that it's a part that's multiplying in each of the values. F of 2, f of 3, and f of 4. Also notice that the common ratio's power is always 1 less than the bounce number. To find the terms for n equals 2, n equals 3, and n equals 4, we multiply the first term by the common ratio raised to the n minus 1th power. So that just means if we're looking for the fourth term, if n is 4, then the power of the ratio is going to be 3. If n is 5, if we're looking for the fifth term, the power of r, the power of the common ratio, is going to be 4, right? So it's always going to be one less number than the term that we're actually looking for. So now that gives us a formula to find any term in a geometric sequence. We just have to take the first term and multiply by the common ratio one less than the actual term that we're looking for. So now we have the explicit rule for a geometric sequence right here. Bam. So now what we're going to do is create some equations for our geometric sequence using that formula. So here is an example. Use the first term f of 1 and the common ratio to write the explicit rule. The first one's done for you. So here it says that the first term is, if the first term is 5 and the common ratio is 4, then our explicit rule is going to look like 5 times 4, which is r, to the n minus 1. Right? So all we have to do is just replace the f of 1 and the r, and the rest of the rule is exactly the same. So for f of 1 equals 18 and r equals 2, we get f of n equals, so f of 1 is 18, r is 2, we get f of n equals 18 times 2 to the n minus 1, right? We don't change anything about the formula. The f of n stays the same and the n minus 1 stays the same. The only thing that changes is the f of 1 and the r. Okay, and then the next one, I'm just going to go through. All of these are the f of 1. All of these are the r's. So now f of n equals, what's f of 1? 3 times negative 3 to the n minus 1. F of n equals, the next one is, the first term is 243. So 243 times r, which is 2/3, to the n minus 1. You see, you literally just plug in the numbers just to the f of 1 and the r. Next one, 500, right, times 0.8 to the n minus 1. Okay, that's it. Let's try some more examples. So this one we're given our terms in the sequence in a table, but this is telling us that the first term is 7, the second term is 14, the third term is 28. So it's pretty much the same. So f of 1 is 7, right? We get that from right here. And then to find the common ratio, we have to divide one term by the previous term. So it can be any one. I could do 112 divided by 56. I could do that. But I feel like doing 14 divided by 7. Can you think of what the common ratio is before I even do this? 7 times what is 14? It's going to be 2, right? But we want to use this method because sometimes we're going to see sequences that are a little more difficult. So 14 divided by 7, that's 2. And now to write the explicit rule, all we have to do is plug in our f of 1, which is 7, and then our r, which is 2. So we get 7 times 2 to the n minus 1, and that's it. So the explicit rule for the geometric sequence is f of n equals 7 times 2 to the n minus 1. No big deal. Next one. Pause the video. You try this one out. I think you're going to be able to do it. So hopefully you pause the video. What'd you get for f of 1? 128, right? And then the next one, the common ratio, I'm going to divide 32 divided by 128. Which that ends up being either a fraction or a decimal, and we can keep it either way. So if you did do 32 divided by 128, 32 divided by 128, 0.25. 0.25. And that's totally acceptable. But if you needed to do it as a fraction, we'd do 32 over 128, and then I think I'm just going to start by dividing by 2 because I can't think of a bigger number. So 32 divided by 2, $16. 128 divided by 2, well, 100 divided by 2 is 50, 28 divided by 2 is 14, so 64. Oh, I know, I can divide this by 8. So that gives me 2 over 8, and then I can divide this by 2 one more time. That gives me 1 over 4, which really is the same thing as 0.25. So it doesn't matter. You can use 0.25 or you can use a fraction. Just depends on what your teacher wants also. Okay, so now we have that our f of 1 is 128. Our r is 0.25. And then we just do to the n minus 1. So the explicit rule for the geometric sequence is 128 times 0.25 to the n minus 1. Or we can also do the fraction one, 128 times 1 over 4 to the n minus 1. Okay, we got some more practice. Good. The more the merrier. So now we have a sequence, 6, 12, 24, 48, and 96. What's the first term of the sequence? You know this. 6, right? How do we find the common ratio? Can you tell what the common ratio is just by looking at it? Sure can. It's just 2. 6 times 2 is 12. 12 times 2 is 24. But we're just going to use this anyway. 12 divided by 6 gives me 2. 12 divided by 6 is 2. So then I get f of 1 is 6 times 2 to the n minus 1. That's my explicit rule. Let's try one more. So we have our sequence 1, 4, 16, 64, 256, and then our common ratio. It doesn't give us the steps anymore. Taking off the training wheels. Can you tell just by looking at it? I can. 1 times 4 is 4. 4 times 4 is 16. Right, so the common ratio is 4. And then our first term, f of 1, is obviously 1. Right, so our explicit rule is going to be 1 times 4 to the n minus 1. And that's it. So try out your homework problems. I think you're going to do great.